Have you ever heard of the idea that our universe might actually be a hologram? It may sound like something out of a science fiction movie, but the concept of a holographic universe is gaining traction in the scientific community. In this video, we'll explore what a holographic universe is, why scientists believe it could be true, and what implications it could have for our understanding of reality. To understand the concept of a holographic universe, we first need to understand what a hologram is. A hologram is a three-dimensional image created by the interference of light waves. Unlike traditional photographs or images, which are two-dimensional representations, holograms have depth and can be seen from different angles. Now imagine that the whole universe is a hologram. According to the holographic principle, this is a possibility. The holographic principle suggests that all the information about our three-dimensional universe is encoded on a two-dimensional surface, just like a hologram. In other words, our reality could be a projection of information stored on the surface of a cosmic horizon. The idea of a holographic universe was proposed in the 1990s by physicist Leonard Susskind and his colleagues. It is based on the idea that our universe is a hologram, that is, three-dimensional space-time encoded on a two-dimensional surface. The idea of a holographic universe was born from the idea of black holes. We all know more or less what a black hole is. Therefore, we can very simply define a black hole as a structure from which anything that goes in can never come back out. But this simplicity leads to a paradox. According to quantum mechanics, information is conserved. That is, if information disappears from one point, it should appear somewhere else. But the general theory of relativity suggests that black holes can allow information to disappear. This paradox is known as Hawking's paradox. Hawking's paradox is a contradiction between quantum mechanics and the general theory of relativity. In the 1970s, Stephen Hawking discovered a paradox about black holes. Black holes are called black because they swallow even light. But Hawking discovered that black holes are actually not so black after all. Black holes emit a small amount of radiation and therefore evaporate. This slow but inevitable evaporation eventually causes black holes to disappear. Black holes suck in everything. One of these things is information. Information is the properties of all particles that fall into the black hole. In other words, information is everything needed to reproduce the original particles that fell into the black hole. This is where the paradox arises. During the lifetime of a black hole, a lot of information goes into it, never to come out again. So when the black hole vaporizes and disappears, where does all this information go? If information disappears from one point, it must appear somewhere else. But the general theory of relativity suggests that black holes can allow information to disappear. To solve Hawking's paradox, scientists are paying attention to the quantum hair of black holes. Quantum hairs are quantum fluctuations in the black hole's gravitational field. These fluctuations vary depending on the mass and rotational speed of the black hole. Scientists propose that information passing through a black hole is stored in its quantum hair. In this case, when the black hole evaporates, the information spreads out into the universe along with the black hole's quantum hair. This theory has not yet been proven. However, it is considered a possible solution to Hawking's paradox. So, what evidence do scientists have to support the idea of a holographic universe? A significant part of the evidence comes from black holes. Black holes are incredibly dense objects whose gravity is so strong that nothing, including light, can escape them. According to the holographic principle, information that falls into a black hole is not lost, but rather stored in its event horizon. This idea was first proposed by physicist Leonard Susskind and has since been supported by various studies, including the famous holographic duality discovered by physicist Juan Maldacena. Holographic duality is a mathematical equivalence between a theory of gravity and a theory of gravity. Holographic duality shows that quantum fluctuations at the event horizon of black holes precisely describe the motion of particles inside the black hole. This is considered an important proof for the holographic principle. This could radically change our understanding of the nature of the universe. However, the idea of a holographic universe has some shortcomings. One of them is that the AD's CFT correspondence underlying this idea has not yet been fully proven. The AD's CFT correspondence is a mathematical relation that equivalently describes quantum gravity in a 5-dimensional spacetime and quantum field theory on a 2-dimensional surface. According to the idea of a holographic universe, the 3-dimensional structure of the universe is a result of quantum interactions on this 2-dimensional surface. However, without proving that the ADA's CFT correspondence is correct, it is not possible to prove that the idea of a holographic universe is correct. Another shortcoming is that the idea of a holographic universe implies that the universe must be very different from what we observe. According to the holographic universe, the 3-dimensional structure of the universe is the result of quantum fluctuations occurring on an empty surface. However, our observations of the universe show that it has the opposite structure. Our universe is composed of matter and radiation and has a well-defined boundary. Therefore, the idea of a holographic universe may need some modifications to fit our observations of our universe. In conclusion, the idea of a holographic universe has significant potential to radically change our understanding of the nature of the universe. However, more work is needed to prove the veracity of this idea. Also, the idea of a holographic universe may need some modifications to fit our observations of the universe. Scientists continue to further investigate the idea of a holographic universe. This research can help us understand our understanding of the nature of the universe and unlock its secrets. Do you think our universe might actually be a hologram? If you think the universe is a hologram, or if you argue that the universe is not a hologram, what is the reason for this? Please share your thoughts with us in the comments. As we come to the end of this video, we would like to thank you for taking the time to watch this video. We hope you enjoyed the content and information we shared with you. If you did, please click the like button below. Your positive feedback motivates us to create more informative and engaging content. Subscribe to our channel and turn on notifications to make sure you never miss a video. By subscribing to our channel, you become an active member of our community. Your participation inspires us to create more content that matches your interests and preferences. So thank you for being part of our community. Hope to see you in our next video. Take care and goodbye.